To find the inverse of a graph when all you're given is a graph and maybe not even given the equation like you have here, we can follow a few extra steps. Let's investigate this just a little bit further. So first I'm going to ask you to identify 3 points that are actually on this dark line, f of x equals 2x plus 1. And the 3 points that I'm going to choose are going to be 0, 1, 1, 3, and -2, -3. So I'm going to write those down. Now I'm going to ask you to find 3 corresponding points on the inverse of this line. So the inverse of 2x plus 1. So 3 of those points might be 1, 0. Another point would be 3, 1. And then another point from the other side would be -3 and -2. Now, what do we notice about these coordinates of corresponding points? 0, 1 was 1, 0, 1, 3 became 3, 1, -2, -3 became -3, -2. Well, what I notice about those points now is that they are just x and y switched. This is the information that I can use to actually graph the inverse of any graph that's been given to me. To find the inverse of a relation of ordered pairs, we simply switch x and y. So let's practice that real quick without the graph, and then we're going to apply it to our graphs. So first we are given a relation of 3 ordered pairs. To find the inverse of this relation, we're going to switch x and y for each of these 3 coordinates. So this becomes 3, 0, then we have 2, 4, and finally -6, +5. Let's see if we can use this information to test if these lines are actually inverses of each other. So one thing we learned from the Patty paper was that the inverses are always going to be reflected over y equals x. So in these type of problems, we are always going to have to identify and draw y equals x. So we're going to use a dashed line to represent that line. And we can first visually inspect. Don't forget to label your line. We can first visually inspect. Does this look like it's a reflection across both sides? Meaning, did it kind of create a line of symmetry between the 2 figures? And it did. And now we can actually explain or verify by selecting 3 points on this line and deciding if they are inverses of each other. So I'm going to select 3 points on this line. I'll pick this point, and this point. So I have 1, 2, and then I have 2, 3, and finally I have 3, 4. And we can find the inverse of those relations by switching x and y. And we get a new relation. So let's plot these points and see if they all fall on the other line. So 2, 1, 3, 2, and 4, 3. They all fall directly on that line, which makes them all inverses and verifies that these 2 are inverses of each other. Even just a simple linear equation can be done the same way. We draw our y equals x reflection line using a dashed line and of course labeling it as y equals x. Then we're going to identify 3 points that are on one of the lines. So I am going to pick -5 and 3. And then I can follow along and pick 0, 2. And then finally, if I follow along, I can go all the way over to 5, 1. The only restriction that you have on the points that you select are that those points cannot be actually on the reflection line, because those points would be like 1, 1, 2, 2, 3, 3. And when we inverse those X and Y coordinates, they become the same exact points. That doesn't help us verify. So inverse of each of these, 3, -5, 2, 0, and 1, 5, 3 and -5, 2 and 0, 1 and 5. Those are all on the other line, so both of these are inverses. Now, what we're actually going to be tasked to do on our assessment is to draw the inverse using our line of reflection and graph it. So it has to use our line of reflection. So once again, we are going to line up that y equals x, draw it in with a dashed line, make sure you label it. But we're going to repeat the similar process we just practiced. We are going to pick, I would say at minimum 3 if it's a straight line. And if it's a curved line, we'll talk about that in just a minute, what points we need to use. But I'm going to pick 3 points. So I'm going to pick 2, 6, 0, 3, 0, 3, and then I'm going to pick -2, 0. Now we're going to find the inverse of those 2 points, or those 3 points. So I have 6, 2, 3, 0, and 0, -2. Let's plot those points over here. So 6, 2, and 3, 0, 0, -2. Now you can use your knowledge from geometry to verify that these really do look like they are reflections, because sometimes with curves it might be a little more challenging, by saying, okay, are they the same distance from the line? So they are 2 over, 2 down, 3 right, 3 down, 4 right, 4 down. And they are, so we've once again verified that we have reflected, and all we have to do is draw our line. Hopefully your straight edge didn't move on you like mine did. There we go. For number 2, we have another line. So I'm going to identify 3 points. 0, 4, and -2, 1, -2. Well, it looks like those are the only 2 that we can find on here. And technically speaking, the definition of a line just needs 2 points, so that's all right. Let's get our reflection line going. Don't forget to label it with y equals x. And then let's find the inverse of these 2 points. So 0, 4 becomes 4, 0. 1, -2 becomes -2, 1. Let's plot those points. 4, 0, -2, 1. Again, they are equidistant from that reflection line, so all I have to do is draw my line. It gets just, for curves, we're going to do things much in the same way. So we're still going to be drawing our line of reflection at y equals x using a dashed line and labeling it as y equals x. But when we're picking points, we have to be a little bit more picky about which points we choose. We want to choose end points and turning points. So here's an end point at -9, -8. Then we have a turning point happening at -1, 2, 3, 4, 5, 3. Then we have another turning point happening over here at 7, -2. It kind of turns just a little bit here at 8, 1. And then again at 7, 9, we have one more point. Now we're just going to find the inverse of each of those listed points. So our first one, we have -8, -9, 3, -5, -2, 7, 1, 8, and 9, 7. And then we're going to plot them. I do recommend that you guys write these in order of how you would follow the line, because it's going to help you graph them later. So the first one we're going to plot is at -8, -9. Notice how it's the same distance away from its corresponding point. Then we have 3, -5. -2 and 7. -1 and 8. And then 9 and 7. And again, each one is going to be the same distance away from its corresponding point. So when we connect these, we want to connect them in the order in which we drew them. And if it's helpful for you to kind of connect them as you go through, that's perfectly fine. Just make sure that you have a curve. For the next one, we're going to start off with our y equals x line. Be sure to dash it and label it. And then let's find those important points. So here's one right here. -9, 6. Follow the curve to the next turning point. We have one at -5, -6. Follow the line to the next curve, and we have -1, 2. And then our last end point is at 9, -6. So the inverse of each of these, 6, -9, -6, -5, 2, -1, -6, and 9. So 6 and -9. And then we have -6, -5. -2 and -1. And -6 and 9. Again, we're going to connect them in the order that we had that we plotted them. And we have our inverse.